I heard about you. I was waiting on you at the door.
They call me a monster.
Okay, well then you ought to take it as a compliment.
Alrighty, my people. Today is Wednesday. Oh my goodness.
Coronavirus! Coronavirus!
There's something in my throat. I do not have corona. Give me a second. Okay. I survived. Today is Wednesday, and we are going to be doing pretty much the same thing that we did yesterday during the Zoom session. So if you didn't join the Zoom, you might be lost. And you need to join it because you got an F for yesterday. And that's my dog yawning, if you heard that. Okay, so today we are going to look at two numerical patterns and see what they look like on the graph. That's it. So here's the first one. Michael and John are creating patterns. So Michael uses the rule add 2 and starts with 1. John uses the rule add 2 and starts with 7. So yeah, we're going to fill this in. If you do not have a packet, you need to get a piece of paper. You need to write Michael's pattern, John's pattern, and a T-chart for the X and the Y. That's it. All right, so if Michael's pattern starts at 1, my first number is going to be 1. And then the rule is to add 2. So now for every number, I'm going to add 2 in order to get to the next number. So 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. Now, John uses the same rule, add 2, but he starts at 7. So his first number is 7. Plus 2 more, 9. Plus 2 more, 11. Plus 2 more, 13. Plus 2 more, 15. I'm going to give you about 30 seconds to fill in your chart so that it looks like mine.
"12 seconds later."
All right, I'm impatient and I can't count. So we're moving on. Now we're going to use Michael's pattern and John's pattern to create the X and Y coordinates. So all we're going to do is we're going to take Michael's first number and John's first number, and we're going to create an ordered pair. Michael is going to be the X value. John is going to be the Y. So the first coordinates are 1, 7. Second ones are 3, 9. 5, 11. 7, 13. And 9, 15. Okay, so now we're going to take those ordered pairs and we're going to graph them. Remember, you always start with the X, and the X is going horizontal. You run first, and then you jump. Horizontal, then vertical. The other day I called people and asked them, which direction does the X coordinate go? And they couldn't tell me. I almost lost it. Okay, so we're going to start with 1 and then go up 7. So horizontal 1, up 7. 1, 2, 3, 4, 5, 6, 7. Boom. 3, 9. 3 horizontally. 1, 2, 3. And up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, you know that I can just follow the rule to get to the next number. I don't always have to start at 0. If I know the rule, I know the pattern, I can just follow the pattern. This is what I mean. So I can start where I left off. And if the rule for the x-axis is add 2, I'm just going to add 2. 1, 2. And what's the rule for the y-axis? Add 2. So I'm just going to go up 2. 1, 2. That's the same thing as 5, 11. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm just going to keep following the rule. Instead of starting at 0 again, I'm going to follow the rule. Add 2, boom, boom. Add 2, boom, boom. That's at 713. Add 2. Add 2. 915. And there you go. We're done. So, even though when you see, sorry, I'm trying to get my words out. When you see the numbers increasing for the x and then decreasing for the y, you will see this happen. You'll see the line going like this. Now, here is the similar problem. Again, Michael is creating a pattern, John is creating a pattern, and we're going to put them together to make ordered pairs. So it says Michael uses the rule subtract 2, and he starts at 12. John uses the rule subtract 2, and he starts at 12. So, do you think we're going to have the same numbers for each person's pattern? Yeah, duh, because they're both starting at the same number and they both have the same rule. So, right now, on your own, you are going to fill out the chart. All the charts. You're going to fill out the one for Michael, the one for John, and the X and Y coordinates.
Okay.
By now, you should have definitely filled out these charts. So let's quickly just go through the pattern, start at the number they say, and follow the rule that they say. So they start at 12. And we're going to keep subtracting 2. 12 minus 2, 10. Minus 2, 8. Minus 2, 6. Minus 2, 4. Minus 2, 2. And then same thing for John's pattern. 12, 10, 8, 6, 4, 2. These are the answers you should have. Now we're going to take those numbers and create coordinates. Michael's pattern is going to be the X. John's pattern is going to be the Y. 12, 12, 10, 10, 8, 8, 6, 6, 4, 4, 2, 2. Okay, so what will this look like on a graph when we have the same X and Y coordinates and they are decreasing? What will that look like? Let's find out. Okay, so you should have, if you have the packet, you should have this graph in there. If not, you need a paper and you need to find a way to graph it. So again, I'm going to give you time. You're going to graph it. I'll try not to forget about you this time. Hey, hi, I'm back. I promise I don't have corona. Okay, so we are going to graph these. I'm going to do 12, 12. So I'm going to go all the way to 12 horizontally and all the way to 12 vertically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I'm going to go up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh no. You know why I don't have them ready for you? I forgot. I was going to make you do it. So you are going to do it. And guess what you're going to comment down below. You're going to tell me what the line that is created looks like. Does it go up? Does it go down? Does it go straight across? Does it go straight up and down? What does this line that will be created after you plot these points look like? So again, there's a few things you could say. Is it going upwards? Is it going downwards as it goes along the graph? Is it going in just a straight line across? Is it going just in a straight line up and down? What does a line that you create after you plot these points look like? That is what you're commenting down below. Or if you can't comment, you're texting me. I don't think I had anybody text me the other day, so you must all have YouTube accounts, right? Ha 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 ha. Huh. All right, here's your exit slip. It's basically the same thing that we've just been doing. So you're going to follow the rules that they gave you for Charlie and Juan and put the coordinate. Follow the rules that they give you for Karen and Monica. Create the coordinates. And then you are going to graph this one and graph this one. Maybe use different colors for each pair. So maybe use one color for Charlie and Juan and another color for Karen and Monica, so you don't get confused with what's what. So complete the chart, complete the ordered pairs, graph the ordered pairs, and then you are going to explain how the X and the Y coordinates are changing. So kind of like you did right now with the comment. Tell me what is happening with the line that is created as you plot the points. Okay, is the line going upwards? Is it going downwards? What is happening? And how are the X and Y coordinates changing? Are they increasing? Are they decreasing as the pattern continues? Okay, you can find this on Canvas. It is a graded exit slip. That means I'm grading you based on what you get right and what you get wrong. The others were for participation. Today is for a real grade.
Mental breakdown check.
Yeah, it's science time. So for science, we're going to be talking about observations versus inference. So when a scientist is performing some type of inquiry, whether it's a experiment or a simulation or a model, they're always making observations, and sometimes they use those observations and create what we call an inference. An inference should be a familiar word to you because all the time you infer in reading. It's actually a skill that you should be using when you are reading. So we know that when you observe, you use your 5 senses to draw conclusions of what you not what you see. Well, yeah, you use sight, but you use your senses to draw conclusions on the matter or the situation that you are observing. An inference is when you use those observations and you use your head knowledge, what you already know, to kind of guess or assume what you think might be going on. So for example, if I see that my chocolate is missing, okay? I had a box of chocolate, it's gone. All the pieces of chocolate in there are missing. And the box is on the floor. And about 10 minutes later, my dog is throwing up. I can infer that she ate the chocolate. Did I observe that happening? Did I see her eat the chocolate? No. But based on what I know about how she acts and how she's a fatty, and the fact that I see her, I can observe her throwing up, I put those together and I make an inference that she is the one who ate the chocolate. Okay, so that's the difference between observation and inference. So, in case you have no idea what the heck I just said, I'm going to show you a quick video on just that. And in the video, the person speaking is going to talk about creating a chart where you say whether it's observation or inference. You are going to do that. So when he says pause the video, make sure you pause the video. BRB.
Hello, nature lovers, and welcome to another exciting video on environmental systems and societies. This one's all about inferences and observations and how to tell them apart. So let me start by asking you, what do you see here? Do you see an insect? Do you see a shiny object? What's the difference between an inference and an observation? Well, an observation you make with your senses. It's what we touch or smell or taste or see. Sometimes we use instruments to make our senses better, like microscopes or pH meters or rulers or stethoscopes. But when we look at this, what's the first thing that comes in your mind? Do you assume that it's some creature, or do you just see the green and the copper and the kind of ridges on its back and these little black hairy looking things coming off its side? Well, if you see that, that's called an observation. Observations are descriptions. So we're describing this object. We're not even saying it's a creature. We're just saying it's an object. And here's what that object appears to look like or feel like. In contrast, an inference is made with our brain. It takes all of those observations that we made with our senses and it puts it together and we make assumptions about it. We say, hey, this thing's got 6 legs, so it must be an insect. Okay, but that's not always right. Yeah, this has 6 legs, but this is actually a spider. Now I know you're probably going, whoa, wait a minute. Spiders have 8 legs. And you're absolutely right. Most spiders, all spiders naturally have 8 legs. But sometimes spiders lose legs. They get in accidents or they have a birth defect or something happens. And so our 8-legged spider all of a sudden is a 6-legged spider. But we made an assumption that because it has 6 legs, it's not a spider. But in fact it is. So we have to focus on observations or inferences. Okay? A scientist doesn't like to use an inference because it's inaccurate. Just because we saw those 6 legs and we said, oh, it must be an insect, we're wrong. Okay, so they want observations. We count or we write down what it looks like or feels like or sounds like, and then later we might work on that as far as making an inference. But to start with, we make observations. So I'm going to ask you to look again at this object. And what do you see as a description? Okay, I'll give you just a second. Matter of fact, you might even want to pause the video and take a look at it and see and write down everything you notice. Okay, now what I want you to do, now that you've written this down, hopefully, if you haven't, stop and go back and do it, is I want you to bring that list to class tomorrow or next time we have class. And what I want to do is I want to share our list with each other and see if we wrote down inferences or observations to see how well we get it. Now that you understand the difference between inferences and observations, we can look at the different kinds of observations. Scientists use these very differently in their research, and one really focuses on precision and one is more of a description, I guess. So the two types are qualitative and quantitative. And if you notice, qualitative is quality, sounds like qualities, and quantitative is quantities. So starting with qualitative, these are very subjective. They describe colors, smells, or sounds, and typically we say it like the water's hot, or the tree is tall, or it smells bad. Those are qualitative observations. So the leaf is red, the garbage really stinks, or the soil is warm in my hands. Those would all be qualitative observations. They're not precise, but they describe something. Quantitative, in contrast, is done by counting or measuring. We almost always use numbers to describe it, okay? So the tree is 31 feet tall, or meters tall, or that weighs 17 pounds. There are 5 parakeets. The elephant weighs 2.31 tons. The black bear is chasing me at 4.6 meters per second. Okay, that's a fast bear. Now, to put it all together, this dirt we could say it's warm, we could say it's soft, but we could also say it's 17% silica. We could say that it's 27 degrees Celsius. We could say that it has a mass of 15 grams per liter. We could be very precise about it, but also descriptive. So we can use both qualitative and quantitative descriptions to observe this soil. And that's typically what scientists do. They don't just do one or the other. I think maybe the quantitative becomes more precise and what they really record and analyze, but the qualitative helps fill in the gaps. It helps them maybe understand why things are what they are, or how they are in comparison to something else. So they're both very important, but you do need to know the difference. I hope this was clear. If it wasn't, please talk to me tomorrow in class or when you see me next. If it was and you're ready, bring your list to class. And otherwise, have a great night. Peace out, homies.
And we're back. So now that you've seen the video, now that you've practiced by creating the chart that he asked you to do, you are going to go on Canvas and you are going to complete the sort. It says observation versus inference. So you did a sort Monday on testable versus non-testable, and now there should be another sort on Canvas that says observations versus inference. You're going to complete that. After you do that, or before you do that, you need to complete the question of the day. Okay? And that is it for science, my people. Again, if you have any questions while you're doing any of this, call me, beat me, when you want to reach me. And that's impossible for all you youngins. So just let me know if you need help. I will be there. We will find a time to talk. If you are one of those people who are not answering the phone but are doing TikToks, we will find you. We will hunt you down. Okay, that's it. Have a great day, guys. Peace out, people.